Let's take a look at standard deviations. So standard deviations are a measure of variability about the mean. And in layman's terms, we would say it's how tightly the data is clumped about the mean. Okay, and so we have some formula that we can use to find this measure of how tightly our data is clumped about our mean, and it's derived from finding the difference between each data point and the mean, and then squaring that, and then dividing by how many data points we have in general. So we have this simpler formula which looks a little more complex, but let's unpack it. So we know that this part here is telling us add your data and then square. And this part here is saying square it first. So square the data first and then add it. Okay, and then here this is just our n, our number of data points, and it's the same n as we have right here. Those are both just the number of data points. And then it looks like we do all of those operations, and the very last thing is to take the square root. So we've done some square roots, just a little bit already, but all we're doing is just typing in that square root button on your calculator. On this one, it's just right there. We're just using that button to do our square root. So we'll just do that at the end. So here we have in words again, this summation. Remember, we say the summation of the x sub I squared means to square all the values first, then add them up. This one where we have the squared on the outside is saying sum everything first, so add all the values in the data set first, and then square your answer. So we have it written in a couple of ways, each showing how we're supposed to do this, and we can handle this formula. All right, let's take a look. And here's an easy way to do it actually, is if we use this nice little chart that we've come up with, we put all our data values in, and I actually ordered them on this chart. So -1, 1, 2, 5, and 10, but they are the same numbers as we had in our data set. It doesn't matter if you order them or not. If you want to, you can. We can find out what our range is by having them ordered, and we can find our median if we have them ordered. And it's easy to identify mode if our data is ordered. I can see I have no mode. 1, 2, 3, 4, 5 data items, so my n is going to be a 5, and that means that this 2 is my median. And again, remember, you do not have to do this analysis. I just happened to because it was all in order there. So first thing I do is to fill in this table is I go ahead and square each value. So for this first one, my data point is a -1, so I'll just say -1 times -1, so I'm squaring it. And I get negative times negative, so it's going to be a +1. And then next one, 1, and I'm squaring that, which means 1 times 1, just a 1. Squaring the 2, so I have 2 squared, 2 times 2, that's going to give me a 4. 5 squared is 5 times 5, so that's going to give me 25. And then 10 squared, that's going to give me 100, or 10 times 10, which is 100. And then it says add them all up. So I'll add them all up. So I have 125, 129, 130, 131. So for that I have 131. And this is the sum of my x sub i's squared. So if I put parentheses on there, they would go right here because I'm squaring first and then summing. So that's what this 131 refers to. Now, if I just add up my initial data values, I would have 10 plus 5 is 15, 16, 17, 18, and then subtract 1, so 17. And that is the sum of my x sub i's, just all by themselves like that. And then if I square that, then I will get 17 times 17, or 289. And that's going to be the sum of my x sub i's quantity squared. So I squared at the end, so it's outside the parentheses. So I can see there that I have all the values I need for my formula, and I just want to rewrite my formula right down here so we can see it when I scroll. So my S for standard deviation is the square root of the summation of my x sub i's squared minus the summation of my x sub i's, and then after I sum them, square them over n, the whole thing over n minus 1. Okay, so there's my formula. Let's plug things in. I can get my pen over here. So I have S equals, take the big square root, and I have the summation of my x sub i's, and this one's the squared. So the summation of the x sub i's, oh, the x squareds first. There we go. The summation of x sub i's squared. So that's this one, the 131. So we take the 131 minus, and now I want the summation of the x sub i's in square later. So that's going to be the 289. So I have the 289 over n. Remember, we counted up. We had 5 data points, so 5 is the n, all over 5 minus 1. Now, some of that I can calculate right away, like that 5 minus 1, I can do that. So my S is going to be equal, big square root, 131 minus, I'm going to just go ahead and put that 5 minus 1 and write down the 4 right there. And then on my calculator, I want to do the 289 divided by 5, so 289 divided by 5 equals, and I get 57.8. So I'll write that in, 57.8. Move my problem up here. Now I want to take 131 minus the 57.8. I can retype all that into my calculator, or I can just change the sign, because I see here, let me get my pointer, I see here that I have a negative 57.8, so I could use that idea, just flip the sign. Now it's a negative 57.8, and then the next thing I would want to do is right here, 131 plus that negative, so plus 131. So I get 73.2, so my S equals 73.2 divided by 4. Now I'm going to do it in the other order just so that you can see it comes out the same, but I want you to try to keep things on your calculator, because sometimes you get decimals that go on and on, you don't want to lose your precision. So on this one I could do 131 minus 57.8, and I still get that 73.2. So you notice that it's equivalent. I can change the sign on that 57.8. So when it was sitting there, 57.8, and I can change the sign using this key right here, the plus minus. So I change it to a negative, and then add that 131. Equals, and I get that 73.2. Okay, we're good with the 73.2. Move on. So 73.2 divided by 4, so divided by 4, and I get 18.3. So I'm still underneath the square root, but I am now down to just an 18.3. So I need to now take the square root of the 18.3, and to do that, remember, it's this square root key right here. So I'll just push the square root, and I get a 4.27, so my S equals 4.2778, and the next digit's a 4, so I'm going to leave it as an 8. So there's my standard deviation. Okay, so I rewrote the formula for you, and I want you to give this table a try. So it's some numbers. Let's take a look if they're the same. If we can. -1, 1, 2, 5, 10, and then we have a new value, this 50. So let's see what happens to our standard deviation when we put that 50 on there. Okay, you guys try that one out. Okay, I'm going to show you how I worked this so that you can see if you made any mistakes on it or what. I need to take -1 quantity squared for this column, so it's going to be -1 times -1, which is, of course, a +1. 1 squared, that'll give me a 1. 2 squared, that'll give me 2 times 2, which is 4. 5 squared, that's 5 times 5, or 25. 10 squared is 10 times 10, or 100. And then 50 squared is going to be 2,500, I think. 50 squared, I know there's a squared button on here. Here it is. There's a squared button right there. You can use that. And it puts it up a high 2 on it. And then equals 2,500. I was right. And then I want to add everything up. So 2,500 plus 100, 2,600 plus 25, 26, 25 plus 4, 26, 29, 26, 30, 26, 31. Let's try that on the calculator. Of the 2,500 sitting there, plus 100 plus 25 plus 4 plus 1 plus 1 equals 2631. Okay, remember this one is my sum after I did the squaring, so sum of the squares. And then over here, if you remember, this first group added up to 17, plus the 50 is going to give me 67. Now I'm good, but I don't know 67 squared, so I'm going to put that one on my calculator, use my handy dandy squared button there, equals, and I get 4489. So that's 4489, and that is the sum of my x sub i's, and after I summed them, then I squared. So that's what that one is there. So those are the two things I need on my formula. So I'm going to say S equals, and since it's written right here and I can see it, I'm not going to rewrite it, but I'll just fill in my values. And I should always write it one time with the values filled in for sure. I need this sum of the x squareds first, and that number is 2631. So 2631 minus, and then I need the squared sum, I believe. So it's the x sub i's quantity square. Yeah. Okay, so it's a 4489. Oh, and we can't read those numbers at all. Let's try one more time. Gosh. Where is it? 4489 divided by n, and did we count these? 1, 2, 3, 4, 5, 6. So my n equals 6. So divide by 6 all over n minus 1, so 6 minus 1. And I know I can do that right away, so I'm going to show that one. 2631 minus, type in that 4489 is already sitting there, that's handy. Divide by 6, so divide by 6 equals, and I get 748, and do you see how the decimals can go on and on? 748.16, and that's actually a 16 repeating on the 6. And we'll put that all over 5. Now it's much more crucial. I need to just change my sign, and on this calculator I push the negative and it's just blank. So I want to say, hey, that number that you just had, put it after this negative. So on this calculator I have a couple of ways I can do it. I can just say, start typing that 2631 minus, and so it looks just like what I had, and then call up that answer. So I do second, and then that negative sign, that brings up the previous answer, which in our case was the 748.166666. So I have that showing, and I'll just push enter, and then I have big square root. My numerator part is 1182. 0.83 repeating. And I'm just going to leave that one sit on my calculator too, because the next thing I need to do, I see, is divide by 5. So I will divide by 5. And my answer now is 376.56 repeating. Okay. The very last thing I want to do is actually take the square root, and remember I can't drop that square root symbol off my problem until I've actually pushed that on my calculator. So that's the last step I want to do now. And when I do that square root for this one, I have to do second and then the x squared button, and it puts a square root on there, and again it's waiting. What are you going to take the square root of? Well, I want it to do for the last number that it came up with, so I'll do second and the negative button so that it'll put answer in there. And then I can push that right parenthesis, but it'll still work if I don't, so I can just push enter. And then my S comes out to 19.4053, and the next digit's a 2, so I'm just going to leave it as a 3. Now look at my standard deviation, it's 19. And on the previous problem, my standard deviation was 4. And remember, all I changed was I used all these exact same data values, and then I put a 50 on there. And the 50 is nowhere near these values. So what happened was my standard deviation got really large because it's saying your data is really spread out. So that's something to notice, because that's what our standard deviation tells us. So the standard deviation here is a 19.4053, and because we added the 50 to our data, is really spread out. Okay, and so if I come back here, we had a 4 for our standard deviation approximately, and now we have a 19. Okay, and that's why, is because we put that 50 on there for our data. Okay, several for you to try here. Give them a shot, and I will have problems worked out for you to check if you have any errors.